Requesting connection. Established. Encrypted. We're live. The show you've been asking for. Advice, technology, and community. Linux first, all others second. This is Ask Noah.
Live from Multispeed Technologies, the Ask Noah show starts right now. This is the show where we came to do all the things on Linux they said couldn't be done and take your questions on how to do the same. The phone lines are open this hour. To be a part of the program, it is a free call, 1-855-450-NOAH. It's 1-855-450-6624, or send an email to live@asknoahshow.com. My name is Noah Chalai. I'm your host. Delighted to be here with you this hour as another episode of the Ask Noah show kicks off. My good friend Bob Carver in studio. Welcome back to the program, sir.
Thank you. Nice to be here.
Yeah, happy to have you. So you and I have been having an absolutely fantastic time since you've gotten into town, and super excited to get you back on the show, but this time in studio, so I think we're going to have a great discussion. So, Bob, I guess I want to start with this. What have you been doing since you've left Sunfire?
Well, I've been designing loudspeakers. I've been designing amplifiers. I've been enjoying myself. I've been flying model airplanes. I've been designing model airplanes. I've been flying my real airplane, and I've been riding horses. I'm retired. So I'm having as much fun as any retired guy could have.
You embody something that I think we have redefined. My generation calls it the Makerspace. I don't know if you're familiar with this, but the Makerspace is basically this idea that kids, when I was growing up, and probably when you were growing up, we would go into a Radio Shack or we'd go into a hobby store, and we would come up with a box full of components and various different things that in and of themselves were not very useful. They're better suited as paperweights than any particular thing, right?
Exactly.
We would combine these things, connect them, and do various different things, and we would build things with them, and that was cool and fun and rewarding.
Yes.
Today, my kids, 8, 5, and 3, they don't do that. They walk into Best Buy, they look for what it is that they can purchase and walk out of the store and put batteries in or plug a cable into and power up, take the cellophane off, and all of a sudden, what does it do for them, right? And I think that's really a loss on society. But Bob, you're kind of the original Makerspace, right? Because so to go back to Makerspace, so what we have done is we have started to reinvent that idea of what can we go back to, what things can we buy, and what places can we go to build things. And so that has manifested itself with things like 3D printing and the Raspberry Pi, the little computer we were talking about before we got on the air, and things like that. Your whole career, your whole industry, your whole business, the very definition of Bob Carver, the public personality, is built in Makerspace. You sit down and you build something. I asked you when you came into the studio, the first thing I said is, how's it been going since the last time I talked to you a day or so ago? And you said, well, I've been designing amplifiers in my head. That's what you do to pass the time. It's a fun pastime for you to design and build things.
That's right. It is. There's nothing more fun than building something. And especially the rewards are enormous when it's finished and it works. And in the case of a stereo amplifier and a pair of speakers, to sit back and listen to them, the rewards are enormous. It's hard to think of something that's more fun than that.
How long have you been designing and building amplifiers and speakers?
Well, I started building amplifiers when I was in high school. I think I was a freshman in high school. It was a long time ago. It might have been junior high. Yes, it was junior high. At one time, I had a choice. I was flying model airplanes, and I could build a radio control transmitter, or I could build an audio amplifier. And I chose the transmitter. I chose the radio transmitter because I thought that would be more fun. So I built an airplane. I built a radio control transmitter to go with it and a receiver. I purchased some servos to move the control surfaces, and away I went. But guess what? After I built it and I was flying the airplane, there was nothing left to do except learn how to fly an airplane better and do tighter loops and better square eights and stuff like that. But,
sure.
So then I turned myself and my efforts to building audio amplifiers, and that's been a lifetime's passion. I've really enjoyed it. It's been challenging. I've been able to do things that nobody else had done before, and that was a lot of fun to see that be fruitful and come to market.
Give me an example of something you've done that hadn't been done previously to you doing it.
Okay. You've heard the expression, what the world needs is a 5-cent cigar.
Yes.
Right?
Yep.
Well, what the world needed was an inexpensive, high-powered amplifier, and they needed a $300 or $400 high-powered amplifier, and it didn't have one. This amplifiers that had that much power were $2,000. So to develop it, I invented something called the magnetic field coil and called it a magnetic field power amplifier. It had a power supply that was different from any other power supply, and it was the basis and was the genesis of an amplifier that I call the M400. Had 200 watts per channel, was a small cube. I don't remember. It was about 7 inches by 7 inches by 7 inches. Weighed 9 pounds. At that time, amplifiers that had that much power and that kind of fidelity would typically weigh 50, 60 pounds and would cost several $1,000s.
Wow.
So that was the first one.
And you built that just because you looked out, you saw a need in the market, you said, hey, I could do that. Was money a part of that discussion, or was it more just, the world needs a thing, I can build that thing. It's a fun challenge to build the thing. If I get paid for it, great. If not, oh well, I still built a thing.
Well, that's very true. That's very close to the reality of my thought process, except I like money.
Yeah, of course. Yeah, we all do. And we all have to eat, right?
Right. So I knew that if I built an amplifier like that, it would be very popular and very sellable. Mm-hmm. And it was. And it put me on the market. It put me on the map. And that was that. After I developed that amplifier, I realized I walked around and went into hi-fi stores, and I was Bob Carver instead of just Bob.
Yeah.
You know? So that was sort of cool.
Let me ask you something. For somebody out there is listening to us, right? And they're thinking to themselves, yeah, but I could never be the next Bob Carver because I'm just Joe and I live in wherever and I don't have any experience and I don't have any real knowledge. And I love science and I love experimenting and I know what sounds good. I think I know what sounds good. I think I don't know. What would you say to that person? Can they build an amplifier? Could they build a speaker in their house? Do they need a big budget? Do they need a big R&D department?
Absolutely, they could do that, and they don't need a big R&D department. As a matter of fact, when I built my first amplifier, I built it in my living room on the kitchen table in the kitchen, and I had some ideas, and it wasn't very expensive. All I had to do was go to Radio Shack and buy the parts, and they were inexpensive. Mm-hmm. By and by, I started making power transformers and things like that I needed for the amplifiers. Mm-hmm. But I brought it to market by myself. I didn't hire anybody to bring it to market. I thought Bose Company might be interested. Mm-hmm. Amar Bose wrote me a letter and said, "Hey, this would be cool." So, but I sent him the circuit diagram, and they weren't interested after that. And I thought that was sort of crazy of them. So I brought it out anyway by myself, and then they copied it. They dead copied it, and it riled me up no end.
Really?
Yeah.
Did you ever feel like you were the small guy? Like you had an idea and you thought, this is my opportunity. You present it to the big boys. They turn you down. You bring it out. Fine, I'm going to do it myself. That had to have been discouraging when they write you a letter and say that, hey, we're not interested in your thing. It's not that great of a thing. Good luck, kid.
It wasn't discouraging.
Really?
No, because the way I responded internally was, "Are you guys crazy?"
Because you knew it was good then.
Yeah, I knew it was good. I knew it would be successful. And I said, nuts to you guys. I'm going to do it myself. And I did, and that was that. It was a blessing in disguise, actually.
Oh, sure, yeah, because otherwise Bose would be the name that we'd all be talking about, and Bob Carver would still be just Bob, right?
Yeah, that's exactly right.
So when you go to build a speaker component or a speaker, if somebody out there wants to do that, obviously Radio Shack doesn't exist. Where can somebody go to buy the components?
You can go online and buy them. They're all available. Everything that was ever available through Radio Shack is now available online.
Parts Express, DigiKey, those kinds of places.
Exactly, and the offerings are vast now. Far greater than anything Radio Shack had. You can buy almost any driver, any cone driver, a ribbon driver. Radio Shack used to have an electrostatic loudspeaker that they sold, and it was great. That's the only thing I don't know that can be purchased right now. I'm not sure about that.
What is the process when you sit down? We were talking a little bit earlier, and you said you don't do a lot of speaker design anymore. Now you've kind of moved on to amplifiers. That's what you settled in for your retirement activity. But when it comes to speakers, how do you go about the process of designing a speaker? If you were going to design a new one today, what would that look like if you were sitting inside of your living room? And let's just say, for the sake of argument, that you didn't have access to a large budget, you didn't have access to some of the industry contacts you undoubtedly have.
It doesn't take a great deal of money. It just takes a bit of perseverance. and an idea, of course. If I were going to design a speaker today, I would close my eyes and I would say to myself, what do I want this loudspeaker to do? Well, I want it to develop a large soundstage that's bigger than life. I want it to have a soundstage that extends far beyond the boundaries of the loudspeakers. I want it to have a soundstage that goes deep back from the loudspeakers. I want it to be all-encompassing. I want it to make a sound feel that immerses one when one listens. And the speakers aren't there. They disappear. You're not aware of the loudspeakers. So I would say that's what the goal is. And then specifically, I would design a loudspeaker to do that.
Is it more of a artistic process, or is it more of an electrical engineer process?
It's actually both.
Okay.
It's slightly more of an artistic process initially when we're thinking about it. When we're thinking about what it is we want the loudspeaker to do. That's very artistic. What kind of soundstage do you want? How beautiful do you want it to be? How close to reality do you want it to be? Do you want it to be real, or do you want it to perhaps sound so encompassing and so enveloping that it's sumptuous, beyond real? And you have to make those decisions and those choices. Most people would say, I want it to sound as real as possible. I don't say that to myself. I put a switch on my speaker so it's click real, and the other way is click what I want it to be.
Yeah, sure.
Which is, in my case, a larger sound field, a more believable sound field, because it's nice to be able to sit in front of your loudspeakers and imagine that you're transported to another place and another space and another time.
I don't know nearly as much about speakers as you do. Of course, I love listening to a good speaker. I love enjoying good music. But one thing I have an extensive amount of experience with is microphones. And it's interesting because the same discussion occurs between microphone enthusiasts. You want a microphone that reproduces accurately, the most accurate reproduction of sound possible. Well, it turns out you don't. It turns out none of us really sound that great.
Right. So, that's exactly right. You want something that sounds better
we can
somehow.
Find a microphone that makes me sound better. I'd rather use that microphone, even if it's not a realistic representation of what my voice sounds like.
And it's the antithesis of an intellectual conversation about what a microphone should sound like.
Oh, absolutely.
Yeah, and so...
Yeah, it defies science, for sure.
Yeah, it does, exactly.
So you order the basic components, you order a driver, you order a tweeter, you order all the various components that you need. Is it just a matter of mixing and matching, or is it a matter of electrical tuning, or both to get various sounds out of a given speaker?
Mostly it's not a mixing and matching. Mostly it's taking a driver, let's say you want to make a two-way system. Take two drivers, one for the mids and highs and one for the bass. And then you put them together, and you make them work together. And you make them work by having them in the right physical position on the driver board. You make them work by having the right frequencies from the crossover go to each one of them. You make the phase from the crossover go to each one of them, especially at the tail end and at the beginning of the bandpass, so that the woofer rolls into the tweeter beautifully without making a mistake. And that's all science, and it turns out experience, which turns into art.
So that is to say, the amplifier sends this frequency to this frequency, and you have a range, and it's sending that to the speaker. It's just dumb. It doesn't know. It just sends a signal. And the speaker then has to break that apart and say, well, these frequencies over here really should be sent to this component of the speaker, and those frequencies over there should be sent to that part of the speaker, and that's what's going to give that clarity and definition of the speaker cabinet. Am I understanding that correctly?
No, that's exactly right. That also is a very pedestrian understanding. It's the first principle understanding of how a loudspeaker works, how a real-life loudspeaker works. The low frequencies are sent to the woofer, the higher frequencies are sent to the high-frequency drivers. And that's exactly what you said. That's exactly correct. Once you do that and listen to it, you sit back and you listen to it and you go, what? That sounds like a loudspeaker. It doesn't sound like a real symphony orchestra playing.
Sure.
And that's what you want. You want it to sound like the band you're used to. You want it to sound like the orchestra you're used to. Ideally, you'd like it to be able to sound like an orchestra if you feed it orchestra music. A rock and roll band if you feed it rock and roll music. A jazz band if you feed it jazz. That's what you really want. And it's possible to do that by having the proper choice of drivers, and more importantly, the wave launch geometry, how the wave leaves the loudspeaker and in what fashion. That's important. The wave launch geometry, the drivers themselves, also the power handling. That thing has to be able to handle all of the power that a symphony orchestra has or a rock band has. And it's substantial.
Let's talk about that a little bit. Explain to somebody that maybe isn't familiar with it, what is your back EMF design? How does that work?
The back EMF design is just for the subwoofer. It's not for the whole system.
Right. But but it's a way to handle power, right?
Right. The conventional way of making a woofer, at least the conventional way it was at the time I developed this, was that a loudspeaker had an impedance, and you put voltage, a varying voltage into it. It made it move back and forth, and that was that. Unfortunately, when you put it in a box, the air pressure in the box made it very difficult to move back and forth. The air pressure would go, the natural air pressure is about 15 psi. And if you put a box around it, the air pressure doubles. And it's very hard. If you go up to a woofer and push on it when it's in a box, it's difficult to push. It takes a lot of force. That force comes from the electricity that you put through the voice coil. The force is equal to the magnetic field intensity times the length of the wire that makes the voice coil, times the current. So it's difficult to do that. And the difficulty has limited the size of woofers to a relatively large box. And the reason for that, I said limited the size, I said it backwards. But a large box has a lower air pressure inside than a small box.
Sure.
So if you have a big box and a woofer and you go up and push on it with your hands, it'll move back and forth easily. If you put it in a small box, it's hard to push. That was the big problem. That's why big bass in small boxes didn't really exist until I came along.
I see.
And all big bass had to come in big boxes. This goes back so far that it's not true anymore, and I don't know if you've experienced that, because most subwoofers today are relatively small. They're not as small as mine, because I took it to the absolute limit. And I got a patent on it, and that was very nice. And today, woofers are not as large as they used to be, and they still have more output. And the way they do it is they have what's called a high back EMF. My invention was a high back EMF, high box pressure subwoofer. High box pressure because the box was small, and when the woofer moved back and forth, the box pressure was enormous. It really basically 30 psi. And remember, even a 12-inch woofer has 78 square inches. So if you add 15, think of it, 15 times 78.
Oh, yeah.
That's a lot.
Tremendous.
That's a lot of force. So the voice coil has to be able to sustain the force. The mechanics of the loudspeaker have to sustain the force without coming unglued, and so on. So that was the genesis of the woofer, recognizing all of those.
And how does the back EMF go about solving that problem?
Well, imagine a regular woofer, and you move it back and forth, and there's let me back up a little bit. Imagine an electric motor, and it's just sitting there freely, and you put electricity into it, and it spins. It doesn't consume very much electricity because there's no load on it.
Sure.
If you load the load the motor by putting your hand around the shaft and grasping it so the shaft is not turning as easily.
Right.
Then what happens is the motor will automatically counteract that force, and its spinning velocity will remain essentially constant, but to keep it there, it has to draw more current, so more power will flow into the motor windings. And if you grasp it even harder, and it takes more force to keep the thing spinning fast, the windings will automatically pull in more current from the power source. And that'll go up to a point, and then at some point, it's overwhelmed, and the motor will slow down and stop as you grasp it more and more.
Sure.
And a subwoofer is exactly that way. A subwoofer is a motor. So if you mount a subwoofer in a large box, the box pressure is low. There's no real force. There's not an enormous force anyway, holding the woofer back and forth. So the current that goes into it is modest. If you put it into a small box, the current has to skyrocket to keep it moving back and forth because the box pressures are enormous. and when the woofer moves into the box,
Mhm.
it has to go against the box pressure to be able to successfully move.
Mhm.
More current has to flow into the voice coil, and when it moves out, it's creating a vacuum for itself, and that vacuum tends to pull the woofer back in,
Sure.
preventing the large back and forth motions that are required to have lots of bass.
Mhm.
And so that was a problem.
Mhm.
Woofers were designed to work, and so the woofers were small enough, drew a lot of current, but were in large boxes so that the forces could be easily overcome.
Mhm.
Yeah, and my high back EMF subwoofer solved that problem. Made it possible to make very small woofers.
So it's yeah, if I'm understanding you correctly, it's almost like the it's not unlike maybe a semi truck. To get it rolling, it creates a tremendous amount of force to get the semi moving. Once it's rolling down the interstate, though, you can kind of back off, and it requires infinitely less energy to keep it rolling or to keep it moving down the interstate. Is that somewhat of a compare?
That's exactly right. Around resonance, that's exactly true. Around resonance, it doesn't take much force to keep it rolling. And fortunately, it's possible to build a subwoofer whose fundamental resonance is lined up with the spectral energy distribution of low frequency energy in music.
Mm-hmm.
And that helps really make it efficient. So when it's actually operating with real music from real program material,
Mm-hmm.
it doesn't require a lot of power, just for the reason you enunciated.
Your name comes up a lot anytime people are talking about home theater, and a lot of people are interested in putting a home theater in their home. Your name tends to come up anytime people are moving past the big box stores where you buy a prepackaged thing and you want something that sounds better, right? Something that has the highest available audio fidelity. If you want that in your home theater, that's when you start looking at products and amplifiers and speakers that you've designed. I guess it was interesting to hear you discuss that you're not much of a believer in multi-channel audio. Tell me about that.
Oh boy. I am and I am not.
Mm-hmm.
I'm a believer in multi-channel audio for watching a TV show,
Okay.
because it's fun to have sounds come off to the left, sounds come off to the right,
Uh-huh.
sounds come from above, especially when there's an explosion.
Mm-hmm.
But when we listen to music, and I'll use an orchestra.
Mm-hmm.
When we close our eyes, we have a sense of depth.
Mm-hmm.
We have a sense of space. And we have that sense of space comes from the way our hearing mechanism works. We have two ears, and the sound from a single sonic event, like as if I snap my fingers,
Mm-hmm.
that's one sonic event. But we can tell where it's coming from. We can tell the space that it's in, all sorts of stuff that goes into our ear-brain system,
Mm-hmm.
allows us to figure out a lot about that sound.
Mm-hmm.
And actually, I've lost my train of thought. When we listen to music, we hear space. Very, very valuable component of the enjoyment of listening to music.
Mm-hmm.
And that space comes from the differential time arrivals
Mm-hmm.
of the two sounds that arrive in our ear. For any sonic event, any single sonic event, we hear two sound arrivals, one per ear. And each ear hears a slightly different sound. And the slight difference in that sound is interpreted and explored by our brain to give us the sound of the space that the music is happening in. It tells us the size of the room, how far away the music is, how far away each instrument is. We can actually pick out individual instruments
Mm-hmm.
in a musical ensemble. And have we got a time here?
Yeah, no, we're more than good. We've got more than half an hour. No,
Oh, okay.
I'll keep track of that.
Okay. The sense of acoustic space is developed because we hear two sound arrivals.
Okay.
For each sound event, one per ear. Now
Mhm.
remember that. Now, if we play that in stereo, we can also hear almost two sound arrivals for each sonic event.
Mhm.
If one of the speakers makes a sound, we can locate it because we hear two sound arrivals from
Mhm.
that speaker. In stereo, we often hear both speakers playing a lot. So we hear 4 sound arrivals. It's not quite as good as 2 sound arrivals, but it's a lot better than multiple sound arrivals. The minute we put extra speakers in the system, say a speaker above, a speaker to the left, a speaker to the right, a speaker to the rear, that turns out to give us many sound arrivals for each sonic event. It's not particularly realistic, but it's the best we can do if we want to hear a soundstage that's bigger than just 2 speakers. But if we're very careful, sit exactly between the 2 speakers, have a microphone that's designed to build a sense of space with 2 channels, there's nothing that compares with it except real life. With 2 speakers, if you're in the right place and you have the right program material, it's unbelievably spectacular. You can close your eyes and you would swear you're in the presence of a real live orchestra. Can't do that with multiple speakers. Your ear brain is too smart for that. You can tell that there's many speakers, and it doesn't sound particularly realistic, but it can be fun to listen to.
It's a novel thing.
Yes.
And I assume that's your not recommendation, but that's something that you also find to be novel for movies as well as TV shows.
Everything. Yeah. Everything's compromised in the sense that
Sure.
you can't replicate real life by watching a movie.
At least not, inexpensively.
Yeah,
Sure.
yeah.
So when you go about the process of doing this, you talk about placing the speakers in the right position. There is a right position. There is a right height. What does that look like? I know that there's a huge push right now to put speakers inside of walls to get them behind acoustically transparent covering so that they can't be seen, to make the space more visually approachable. What's your thoughts on that?
Well, it won't work, of course. So if we're audiophiles, we would never even consider doing that because it doesn't sound good. It can't sound right because there are too many sound arrivals per sonic event. The sound comes out of the speaker, it hits the wall as it comes out, it makes more sounds, that sound hits the wall, makes multiple sound launches, and it destroys the sense of acoustic space.
So when you sit down, if somebody hands you 2 speakers, let's say we're going with a 2-channel system, how do you go about, you have an empty room, how do you go about determining the right size of speaker for the right acoustical space? Is there any treatment you do to the space itself? Where do you place the speakers? Where do you place the listener? All of those kinds of things.
Well, if somebody handed me 2 speakers and they were relatively small, maybe 5 inches, 6 inches.
Well, let's say we're talking about the CRM2s.
Okay, yes, relatively small. Those speakers are designed not to have secondary wave launches. If a single sonic event is put into the speaker electrically, it'll make one sonic event come out, almost, not quite, but close. And so the way to position those speakers is away from a wall, away from a back wall, away from a side wall, away from anything that's reflective that would generate an extra wave launch when the initial wave coming out of the speaker hit it and bounced off. So the position is, you put 2 loudspeakers, let's say on a small stand at ear height, and extend your arms out at, say, 40 degrees each, and that's where the speakers would be. And then play the music and sit between them. And the secret is to minimize the extra reflections that occur off of the boundaries of the wall and the room. When you hear that sound, what your ear does is take the sound from the left speaker, and also the left ear gets sound from the right speaker. That's a slight flaw in the ointment, but not a big one, and vice versa. And what happens is our ear brain makes a big, huge panorama of sound out of just 2 small speakers. And you can read magazine articles that talk about that. And it's delightful to listen to. It sounds so real and so realistic, and it's such a desirable sound. It's tough to get because you have to be careful with the room acoustics and not have things bouncing the sound around. You want it sort of dead up where the speaker is. And the other extreme is an ambience kind of speaker, like a Bose 901, which has multiple drivers, and it's designed to bounce the sound around the room. And it does. And that's sort of that can be very enjoyable to hear a multitudinous of different sounds bounced from the walls. It gives it a nice echoey sound, and that's very pleasant as well. But it's not nearly as accurate. It's not as realistic, and in my view, it's not as enjoyable as having a true stereo system that I just described. Right.
So in a perfect world, then, if I'm understanding you correctly, we would deaden the entire room.
Almost.
You want as much of because you can is the idea that we can reintroduce echo if we need to once we have a dead room and we have control over those 2-point sources?
Well, of course we can do that. I prefer to have the dead room up front where the speakers are and then have it live behind me. And that's called a live end, dead end room.
I see.
And it's very effective, and it is extremely effective. And you use the room itself to generate the ambience and the echoes that we need to make it sound real and big and live.
Sure.
And yet, from the front, you're getting pristine sound launches that are uncluttered with sound launches that will only mess up the sound.
How do you go about deadening the front of the room? What do you recommend?
Couches, chairs.
Oh, really? That low tech, huh?
Carpets, yeah, very low tech. And if you want to, put some sound absorbing panels on the walls, and they're very pretty ones. You can get them that look like photographs, that look like pictures on the wall, or they're just very attractive sound absorbing panels with colors.
So when you say these modern approaches to audio for home theater are not necessarily ideal because they don't sound good, what is the primary factor? Is it the fact that it's in wall? Is it a fact that they put acoustically transparent, supposedly coverings over them? What factors contribute to it not sounding great?
It's all of the above.
Okay.
It can sound great, by the way. I mean, a home theater can sound great, can sound compelling, and it's fun to listen to. It's sound everywhere. However, it lacks the timing information that we have in a stereo system that I just described, or in a real life scenario. And that's the slight timing, that's the slight difference in arrival times of the same sound, both ears. That goes away when you do surround sound. And so you lose that information.
Now, what if you had in-wall speakers, you had, coverings or whatever, but we're just still talking about 2-channel. Any degradation in sound quality there?
Not as much. Not as much. Again, what makes the best 2-channel experience possible is where you have the 2 speakers and they're delivering sounds that are devoid of early reflections or secondary wave launches. And you have to, it's troublesome to get there. And if you read some of the descriptions in magazines, the speaker should be away from the walls. It should be relatively small. It should be up on a stand. So there's nothing in the way of the sound and the wave launch. Once you put it against the wall or in the wall, all of a sudden the wall itself is reproducing sound and sending out wave launches.
You have, and actually this should really speak to the idea that somebody does not need a large budget to produce speakers. Your lab, Bob Carver's lab, is really your old house, isn't it?
Yes.
And so, I mean, you don't have some, I'm sure there's, there's very high quality equipment inside of it, but it's not like you have some massive warehouse with hundreds of thousands of people that are all coming around and scientists running around in lab coats trying to do this. It's you sit down, you listen to the music, and you say, that sounds good, that sounds like garbage. Let's make more of the good and less of the garbage, right?
That's exactly right.
What does your listening room look like? Describe that?
It's a large room that's upstairs. And I look out the window and I see a garden, and I see a wood, and I see woods. If I look out the front, I have to go to the other side of the house, and there's a street there. But it starts out with a nice sense. You have a nice feeling when you look out and you see woods and flowers and things like that. The inside is just some. There's a couch on the left side, normal furniture. I designed my speakers to be in a real house. So I design them in a room that's supposedly like a real house. I call it my standard living room.
You've standardized the living room.
That's right. It has a couch and some chairs and some tables, stuff like that, to make it seem like a real living room. And from that, I designed the acoustics of the loudspeaker.
You okay taking a call?
Absolutely.
855-450-NOAH. That's 1-855-450-6624. George in Denver, you're on the Ask Noah Show with Bob Carver and myself. Good afternoon.
Hey, thank you. I think I had a pair of Carver speakers at one point in time. Anyway, this whole topic conversation is quite fascinating to me because I've been involved with music most of my life and synthesized music for at least 10 years. And right now I play a piano. Are you familiar with the piano at all?
No, I'm not. Describe it.
It's a virtual piano that is modeled. It's mathematically modeled. It's not sampled. And what I found very interesting in your conversation is how you're talking about how smaller speakers. Because what I noticed with the piano, having bought just fairly inexpensive computer speakers for it, that it sounds much better with a smaller woofer or subwoofer, whatever they're calling it. The slightly it's a very small, comparatively small speaker. In a say like a 10 by 12 box, and the speaker is much smaller.
Certainly.
But what that does to the piano is it gives the upper overtones of the lower bass strings, and that's really what gives an acoustic piano its characteristic sound. You have to, you can't just hear the fundamental note itself. You have to hear the overtone partials that are a part of the string sound. So.
Of course.
I don't know. No, I just find the whole topic kind of fascinating, and I just want to bring that up. And I'll say one more thing, and then let you continue on. But recently, I bought a Samsung Tab 5 SE. It has 4 speakers in it that are very, very tiny, really. But the sound is quite remarkable. And when you set it flat on a table, it changes it quite a bit and improves it considerably. And I find it fascinating how, as time has progressed, how they're managing to get better and better sound out of very, very small speakers. So if you could just kind of elaborate on what I've said, I'll let it go with that.
Certainly. What you said is absolutely an expected result from a scientific point of view. A small speaker actually can make better sound than a big speaker often. And the reason is that the extraneous wave launches that accompany a large speaker are gone in a small speaker. What we want for the best fidelity is to have one sound leave the loudspeaker for each electrical sound input. With a large speaker, very often there are multiple sound launches, wave launches for a single sonic input. And that tends to make the sound not as realistic in a dimensional sort of way when it goes and flows, when it goes from the speaker into our air-brain system. In other words, when we listen to real life, we hear 2 sonic events, or we hear two sounds for each sonic event, one per ear. When we listen to loudspeakers, though, we hear many more than that, and that destroys a lot of the realism. So a loudspeaker that's very small and is designed specifically to make one sound, and only one for a given input, will always sound more realistic, provided the rest of it's good, that it's flat, has nice tonality and stuff like that, and low distortion. Especially when you have 2 of them and you space them such that you can listen to them with 2 ears, more or less on the equal partition plane. And it's.
Do you have any thoughts on tube amplifiers as compared to transistor amplifiers? Now, tube amplifiers, in my opinion, have completely gone out of fashion. But in the early days, when transistor-style amplifiers were first coming out, I always considered the tube amplifiers to sound better, and I know in the early days of synthesis too that there's a feeling that tubes generally are better than transistors. I'd just like to get your feeling on the subject.
Well, tube amplifiers have had a resurgence Everybody loves the way a tube amplifier sounds, and tube amplifiers sound a particular way because of the way they integrate with the loudspeaker. The loudspeaker has an impedance, and the amplifier operates against that impedance and can generate a sound of its own. So each amplifier, especially if it's a tube amplifier, will have a unique sound and a sonic signature of its own. And each one will be slightly different. And people like that. Solid state amps, on the other hand, typically do not have a sonic signature of their own. And the reason for that is that their output impedance approaches 0. Whereas on a tube amp, it's between 1 and 3 and 4 ohms. And that makes the speaker, that gives the speaker the ability to respond to the room, act like a microphone in reverse, feed that signal back into the amplifier amplifies it, and it makes the loudspeaker sound way different in a room than it would be if it were driven from a solid-state amplifier for that reason. And it's often an enjoyable sound.
Does that answer?
Well, I think the thought was that tube amplifiers are warmer sounding, and again, I think all of this has improved over time greatly. But originally, I guess transistors were just kind of hard and dry.
By
I'd characterize it.
Well, by comparison, they were, but not because of the transistors. It was simply because of the output impedance of the amplifier. A tube amplifier has a high output impedance. A solid-state amplifier, transistor amplifier, has an output impedance approaching 0. That makes the speaker sound vastly different, especially in a room. If it's driven by a tube amp, think of it this way. The sound leaves the loudspeaker. It bounces around in the room, bounces off the wall, comes back to the loudspeaker. The loudspeaker acts as if it were a microphone in reverse. That voltage is fed to the input of the amplifier, and it reemerges, and you hear it. And you hear it as the warmth of the room. In other words, it's reproducing the sound of the room more than a solid-state amplifier would. If in a solid-state amplifier, the sound bounces off the wall of the room, returns to the speaker, that voltage is then sent back to the amplifier input, except it's not, because it's shorted out. Since the output impedance of the solid-state amplifier is essentially 0, it's shorted out, and that voltage never returns to the room. You don't hear it, and it makes the room sound. It makes the amplifier sound slightly smaller, a little more sterile, perhaps. Certainly not with the warmth of the room.
Bob, didn't you at one point design amplifiers specifically to compete with tube amplifiers to show that a solid-state amplifier could perform as well as a tube amplifier?
Yes, I did.
So you can, with the right electrical design, you can make a solid-state amplifier sound the same as a tube amplifier, but lately you're actually starting a process in which you're designing amplifiers to, as you put it, to have different acoustic signatures.
That's right, exactly. I give my amplifiers the acoustic signature that I like.
Does that answer your question, George?
Yeah, I got one more, if you don't mind.
Sure.
What's his opinion on oral exciters? I've really seen it demonstrated only once. Bo Tomlin gave a workshop on synthesis, and he showed how oral exciter, which his explanation was it kind of adds trash to the sound, really enhances the warmth. I'd just like to get your opinion on that.
It's been a long time since about 20 years ago, I analyzed the oral exciter, and I'm having to search my memory banks right now. But as I remember, it modifies the input signal. It warms it up quite a bit. It allows the room to feed back into it through the loudspeaker, and it excites the room. And I don't know why they put the word oral in there, but it's the way it works. It actually does excite the room a little bit. And I thought it sounded just great. Yeah,
it does. It does make a huge difference. Okay, well, thank you so much for taking my call. I really appreciate it. And if you can explain how a Samsung tablet can sound so great, I'd be interested in that too. But thank you.
We appreciate the call, George. Again, 855-450-NOAH. That's 855-450-6624. The email, live@asknoahshow.com. You can also join us in our interactive mumble room. We'd love to have you either way. By the way, take another moment just to mention our call widget. You can head over to asknoahshow.com. There on the lower right-hand corner of the page, you can click on live call. Hey, all we need is a web browser. You got a web browser, you got a headset, you can join us right here on the program. We don't collect any information. You don't have to sign in. There's no account creation necessary, and you can join us on the program. We'd love to have you that way. Bob, I want to ask you this. BobCarverCorp.com, that's your website. This is your retirement project, essentially, right? You're exiting the industry, as you keep saying. You're retiring. You've been doing it for 40 years. You're ready to be done. But at the same time, you've still got a boatload of passion and you don't know what to do with that. And so what you've done is you've taken it and said, okay, I'm going to go back and I'm going to work on toys that I want to invent and I want to play with and things that I think should exist. Whether or not they're profitable, I just want to make them. And as part of that, you have brought back one of your coolest speakers ever, and that is the amazing Line Source. Tell me about that speaker.
Well, the amazing Line Source is a loudspeaker that is approximately 5 or 6 inches in diameter. It goes from floor to ceiling. Mm-hmm. It bumps into the ceiling and it bumps into the floor. And imagine the floor and the ceiling a mirror. If you look at such a device mm-hmm. and look at it, it looks as if it goes to minus infinity because you see the reflection in the mirror. And looking at it from looking at the top of it, it seems to go to plus infinity. Mm-hmm. And that's what a mirror does visually, but a normal floor and a normal ceiling will do the same thing for sound. So we have a Line Source that's not just floor to ceiling, but goes from way below the floor to way above the ceiling. And such a loudspeaker can launch a wave that gives us a sense of acoustic space and fidelity that's not really available, in my opinion, any other way. It makes it, when you sit in front of a Line Source and listen to it, it sounds like a real live symphony orchestra or a real live jazz band or a real live rock and roll group. The sound extends beyond the speakers, left and right, above the speakers, into the ceiling, and far, far back from the speakers. It's not a flat curtain of sound strung between two speakers. And normal speakers produce a flat curtain of sound strung between two speakers.
Would you recommend such a speaker for a home theater environment, or is it really more for just music listening?
It's, I think, really more for music listening, but it's for both. I mean, every time I've used a loudspeaker that I've loved mm-hmm. in home theater, mm-hmm. In stereo, mm-hmm. and hooked it up to home theater, I liked the way it sounded. It sounded spectacular. I also believe that it doesn't need to be that. It can be a regular set of speakers and can sound spectacular, provided the musical information is correct to make it sound that way.
So the source audio obviously being a very important thing. And you have, I know you do so many interviews and are so busy, I'm not sure if you recall, but you and I had a very in-depth discussion on 192 kilobit sampling and the ultra high fidelity audio and the community that has erupted around that. And so that is the idea of, even though the vast majority of people get their music at 320 kilobits from Amazon.com, just download it as an MP3, there are those of us that still search for the highest uncompressed source. Oftentimes even going back to get, original Santana recordings that before they were doing digital sampling and stuff. It was interesting on the way, when I picked you up from the airport, on the way into Grand Forks, one of the things that you said to me, which I thought was very interesting, you don't believe there's any degradation let me rephrase. You don't believe that there's any inherent limitation of a digital audio system as opposed to an analog audio system. Sometimes the implementation just isn't there.
That's correct.
That's interesting.
Intrinsically, there shouldn't be. And it does not need to be super duper high bit rate and all that. All that happens when you reduce the bit rate, if it's done right, mm-hmm. is the signal to noise ratio is hurt. The noise floor is not as good. So what that means is that if you stop the recording and listen, you'll hear a hiss at the bottom, which you wouldn't if you had a higher bit rate. You'd hear dead silence. So what?
Sure.
I mean, even analog has a noise floor that's hissy.
Sure.
And we love it, and we live with it, and
mm-hmm.
and it's
we embrace it.
We embrace it because it doesn't sound bad. That's why we embrace it. That's all that happens.
I'm going to get to a piece of feedback, and then I want to talk a little bit about your website and where people can engage with you. As always, you can send feedback to live@asknoahshow.com. We'd love to have it. We'd address your questions, your thoughts on the air here at the end of the show. This week, Scott writes in. He says, "Hi, Noah. I've been listening to your program for quite some time, and you're a gold mine of information. I appreciate all the work you do for the community. Recently, I've been experiencing some some trouble with my current gigabit D-Link unmanaged switch. I recall that you don't like Ubiquiti switches, so I looked up on Microtech's site. I'm wondering if I can get your thoughts on these two. The product C lists are the CRS12524G1S in and the CS32624GS2S Plus RM. Pricing on them both seems very reasonable. Only concern I have at this point is that it may be too difficult to configure the thing. Thanks, Scott. So let's start with this. As far as my dislike for Ubiquiti switches, if you're in a home environment and you don't need stacking, true multicast, if you don't need IGMP layer 3, if you don't need NetFlow, if you don't need PV, STP, if you don't need officially supported out-of-band management, and if you don't need TAC ACS, then Ubiquiti switches are fine. If you start to get into small business or enterprise environment and you're dealing with enterprise level networks, then Ubiquiti switches start to fall apart. And it's a frustrating conversation to me, to be very honest with you, because Ubiquiti makes a very high quality product. They just designed their product not necessarily to be for the thing that people try to use it. They try to cram them into situations that they don't belong. Now, that's not Ubiquiti's fault. That's the fault of the user. So it's not necessarily that I don't like Ubiquiti switches. I just all too often find people trying to use them in places that they don't belong. So if you want my overall recommendation for a switch, if you just written into the program and said, I just want to switch, what would you buy? I would tell you to buy an HP 1924 port switch. That is a great go-to standard. It has all of the features and functionality with Cisco without the pretty price tag of a Cisco switch. It functions beautifully. The web interface is very easy to learn. Out of the box, it's going to function perfectly, just like your unmanaged switch would. But when you desire for those to escalate in features, those features are going to be there. Of the two options that you gave me, I would go for the CS 32624G2S Plus RM. And why? Because I have experience with it, and I don't have experience with the CRS 125. So I would tell you to go through 326. The reason I don't use a lot of Makertech switches, even though we use Microtech routers all the time, is frankly I think HP makes a better switch. They're about similar price points. The HP is a little bit more expensive, but you're really getting something for that money. The other thing I really like about HP, it has an insanely intuitive CLI. So if you SSH into the switch and you need to manage it from the CLI, which, let's face it, some of us have to do from remote sites sometime, the HP is going to be a better choice. Again, hope that answers your question. If not, you can write back to live@asknoahshow.com. We'll take it in another episode. So, Bob, as we just a couple minutes left in the program, I guess what I want to close with is I want to talk a little bit about your website, bobcarvercorp.com. You have a history of you come up with an idea, you build a company around it, you grow it to success, and then you've sold it. And that's kind of been a history. That's what happened with Carver. That's what happened with Sunfire. Is that what happened with the Phase Linear as well?
Yes.
So that's been kind of your modus operandi. Bob Carver Corp is something different. It's more you and less business. It's more your passion and less of market desire. It's a very niche audience. You're building. That's why I laughed when our friend George was chatting with you about tube amps. You're building tube amps right now because you think they sound good and because that they have this characteristic that you really like and want to bring back. Talk about that.
And they're fun to build. I can make a solid state amp sound like a tube amp, and I can almost make a tube amp sound like a solid state amp. So there's an ability and a technology there. Mm-hmm. So why am I building tube amps? Why not just build a solid state amp and make it sound like my favorite tube amp? And the reason is that it's more fun. It's actually a lot of fun to build tube amps.
Is it because it's challenging?
No, it's just fun. I think it's because I grew up with tube amps. As a youngster and as a teenager, all they had were tubes. They didn't have transistors yet. And so I built tube amps, and it was a lot of fun. And today, it's much more fun to watch a big tube amp with its glowing tube sitting on the floor.
It has ambiance.
And you're listening to music, and you're listening. Oh, it's just, there's nothing like it. You listen to some beautiful music from beautiful speakers, and there's a big tube amp on the floor sitting there. I mean, looking at a solid state amp on the floor is nothing in comparison.
And in North Dakota, where it gets to be 30 below zero, the louder the music is, the less your heating bill is.
That's right. That's right. You save a lot of money with a big tube amp and the heating bills.
So people, if they're interested, Bob, they can purchase these custom-made tube amps. You sell mono amps, you sell stereo amps, but all of those, plus your amazing line source speakers, are available at bobcarvercorp.com. Is that right? And
that's right.
You can purchase them there. Are you still doing the custom enclosure deals where people where you were making various paint jobs and stuff like that?
No, I don't do that anymore.
Okay. Well, that's cool. So bobcarvercorp.com is the website, Bob Carver. I don't suppose you're on Twitter or Facebook or any of those things?
No, I'm not.
No, you just come on.
But some people have put me there, and so there's some.
I don't think that counts. Well, they can join you. Come back on the Ask Noah show. They can chat with you here, huh?
Uh-huh. They can actually, anybody can just look at my website and send me a letter from that. Or
they get a hold of you.
Email me. I'm easy.
There you go.
In fact, I think my phone number's there. You can call me.
There you go.
I keep my cell phone in my pocket at all times, and it's on, and I'm open for business.
That's awesome. Well, Bob, thanks so much for taking the time to join us. We really appreciate you coming on the program and chatting with us and explaining your passion for audio and high-definition audio, home theater, all of those things. It's been fun. We'll get you back on the program soon.
I'd be delighted.
Yeah. That'll be great. And we have the best of the week for us anyway. It's just getting started. Like, we've got a whole bunch of experiments lined up downstairs. We got speakers. We got microphones. We're doing tons of testing.
That's right.
All right. Well, thanks again, Bob. Hey, did you know this show is available as a downloadable podcast? That's right. You can check it out by going to podcast.asknoahshow.com. You know, we're talking about Bob Carver Corp and all of these various websites and things you can order. Hey, that's where you can find the links to all those. Again, podcast.asknoahshow.com. The Ask Noah Show continues next Tuesday, 6 p.m. Central. A huge thanks to Sarah filling in for Call Screener and JT, our executive producer. We'll see you next week.